The National Council of Teachers of Mathematics created this visionary document, the Curriculum and Evaluation Standards for School Mathematics, to guide the reform in mathematics education. The integration of technology in instruction at all levels is one of the significant themes. In particular, using the calculator as an instructional tool is recommended as an effective teaching strategy.
If you remember, what we did is we had a setup with the corners being cut out of each, and then by doing that, ending up with a box. Of course, you guys can do about anything you want to in terms of cutting the corners out. If you have squares, you'll get a box, obviously. But whether or not it's the box with the maximum volume is the big point involved here. So you're going to have to come up with the equation and show the curve graphically so that you can zoom in on that maximum volume for your particular one. And no two are the same, therefore somebody else's box may look completely different than yours according to the dimensions of their particular rectangle. Okay.
Teachers find all students benefit from having calculators available to investigate mathematical concepts and to develop problem-solving abilities. Calculators enable students to explore ideas and patterns that were previously inaccessible to them. Students are now able to focus on understanding problems, not just generating answers. They quickly learn to decide when it is appropriate to use a calculator.
So you worked out an equation that matched the graph?
Yeah, it matched the graph. The graph was like a 0.5.
The highest point here is the volume of the box.
Our greatest volume.
Yeah.
We zoomed in on this greatest point right here to get the maximum volume, to find out what it was. And that's how we found out what Y was. So our greatest volume was going to be 8,105 point something. And then we found out what X was, and that's how we found out how much to cut out to get this greatest volume.
These students use zoom in to find the dimensions of the box of maximum volume. This technique is an example of the powerful methods that graphing calculators allow. Numerical and graphical methods, such as zoom in, provide students access to problems that would otherwise be studied much later in the curriculum. Most importantly, students increase their opportunities to think mathematically when using calculators.
We use the graphics calculator over top of the computer because the kids could take it home with them. They could work with it in the study halls and always have it available to them. It was a night and day situation. We were able to do things graphically that may have taken us weeks to accomplish in a matter of days.
Okay, what we're going to do today is we're going to look at some of the different buttons that are on your calculators, because your calculator is actually a function machine. And we have been studying functions, and I want you to begin to understand how the calculator works, because if you can understand how your calculator works, you'll understand functions better. The third thing that I want you to do is make a graph of the information that you have gotten from your calculator. And the fourth thing that I want you to do after you've done all of this is to figure out what the domain and the range are.
0.00, how are you going to graph 0.0000?
We'll edit it out.
Scientific calculators without graphing capability are also useful tools for exploring functions. For example, this activity demonstrates an effective way to introduce students to the graphs of functions.
I plotted my points right here with like negative 0.5 to 30, and I did it for all of them, and I just connected the dots and I got a curve. You know, she said you can't get a straight line, so I got the curved line, and that's how I knew I got the right answer. After I plotted them, I just connected them.
In this particular exercise, the kids are struggling with really the meaning of what a function is as they're using the calculators. and I'm able to work with more advanced functions. When we didn't have the calculator, we had to use very basic functions, and I don't think that the concept was as clear to my students.
Some of the advanced calculators are really computers that fit into the palm of your hand. With large screen graphics displays, they are interactive and programmable. They also have printout capability and can store and recall programs from tape.
Calculators have changed the way I'm teaching in the sense that this year we're using a calculus book that requires that the students have a calculator, a graphics calculator available to them. They're exploring whether a function is increasing or decreasing by looking at the graphs, by calculating what happens at a point on the graph. They have had the option of looking at finding the area under a curve as an introduction to the idea of a definite integral by actually counting squares. The graphics calculator gives them the squares to count. We are right now have been investigating the relationships between the graph of a function, the graph of its derivative, and the graph of the second derivative. These particular activities I've done before, but we've always had to do them by hand, and we haven't had as neat functions to work with. Now they can do more than one and do them very, very quickly and see the relationships.
We see that when the double derivative is positive, the function itself is concave upwards. When the double derivative is negative, the function itself is concave downwards. And so the whole summary of this is that by graphing it, we found out we found out the relationship between the graphs. Okay, that's pretty much it.
The absolute value of x plus 2 is greater than the absolute value of x. And we're going to look at several different ways that we can solve this. I want to now look at a calculator solution. Can we solve this graphically? Get out your calculators, and I'm going to ask you some questions, and let's see if we can solve this graphically. Now, Jerry, how would you set this up for a graph? What would you suggest as a possibility for a solution?
Well, I would set y1 equal to the absolute value of x plus 2.
Okay, let's do that. Absolute value of x plus 2. Okay.
Okay, and then set y2 to the absolute value of x.
All right. Let's graph it, Sean. Does that tell you anything about the solution to this problem? Does that tell you where the absolute value of x plus 2 is greater than the absolute value of x?
Honestly, the two absolute values intersect right around -1.
Okay, the two functions intersect at -1, and this function right here is the absolute value of x plus 2, where it crosses the axis at 2, and this is the function of absolute value of x.
All right, and physically what's happening where the absolute value of x plus 2 is greater than the absolute value of x?
It's above it on the axis.
All right, it's above it in your picture. Yeah, key point. Okay, thanks, Marcia. Now, Becky, looking at this, how do we find on our calculator where these two intersect?
You can use the trace.
Okay, so you're saying use the trace function, and the intersection is?
-1.
-1. Okay, now, Stephanie, we're going to go to you next, and can you think of another way we could solve this problem?
For y3, we could put in y1 minus y2.
Okay. Now, what's the graph of this going to look like, Stephanie, before we put it up there? What are you going to get?
It's gonna at -1, the graph will go above the x-axis.
Okay. So Stephanie says if we take this one, which was absolute value of x plus 2 minus the absolute value of x, she says where this is positive, that is a solution. Now, Vanessa, which of the solutions did you like best and why?
I like the y1 minus y2 because it gave the easier picture of where the negative 1 was.
All right. Where the negative 1 was, you said is very graphic from there.
Yeah.
Okay. Alex, how about you?
That sounds good to me.
That sounds good to you too? All right. Does it make it easier for you to understand this?
Well, yeah, because you can actually see what's going on when you're doing it. You can actually have a picture of it instead of just a bunch of letters and numbers on a board or on a paper.
I liked the y1 is greater than y2 because it was the easiest for me to interpret on there because you could see precisely where it was.
Yeah, and I would tend to agree with you there. That's what I find too. That's the way it was when I first saw this problem.
As you can see, the graphics calculator makes a tremendous impact in a mathematics classroom. In all my years of teaching, I think this is the most exciting development that's ever occurred. My classrooms are changed, and they're changed positively forever as far as this technology is concerned. It makes math a visual subject where it's never been before. It takes away a lot of the computation that we have been laboring over and allows us to go deeper into looking at mathematics and its patterns.
Without the graphing calculator, it would be impossible to do what I'm doing right now. I would be able to draw one picture in a period, and that's it, and be able to talk about it, compared to being able to maybe graph 20 or 30 different pictures and different views of that same graph.
If I were talking to someone who was hesitant about using the calculator, I would say jump in with both feet and enjoy it. It's just a marvelous experience.
I think everybody should go ahead and try it because it really does work and it's really a lot of fun.
The mayfly hatch that we're seeing on Silver Creek now, characteristic of midsummer, is the famous trico hatch. It is a extremely small black and white mayfly, size 20 to 22. It comes off in unreal numbers, sometimes clouds where it limits visibility. A fish will come up and slurp and sometimes take a dozen at a time, and you just hope that one of your tiny flies on 7X tippet is in that group of flies that it takes. There are 3 or 4 dominant aquatic plants that grow in the creek. They offer habitat for the aquatic insects, and of course the fishery itself, as they force the stream into narrow, deep channels sometimes, and the fish can get down in there and feel secure. Along with that, the aquatic plants are so important to this habitat that some of the information we've gathered on the entomology of the stream has determined that no other stream in the world has been recorded to contain aquatic insects in the number Silver Creek does.
Unique as Silver Creek was, buying it for $500,000 was a big step for the Nature Conservancy. But fly fishermen were worried about losing the stream back in 1975.
These fly fishermen who used this preserve, or not preserve, but the property then, were up in arms and concerned that developers were going to purchase it. What we did was we came in and we gauged the amount of public interest in the project and decided that we would take it on and just raise the funds. A Fish and Game Department study was in the process of being completed at that time. It verified the questions of many, many fishermen over the years that Silver Creek's fishery was in a state of decline. And in fact, when the study was completed in 1977, I believe,